In this problem of trigonometric identities, on the left hand side I have tangent of x upon 2 plus 45 degrees plus cotangent of x upon 2 plus 45 degrees, and on the right hand side I have 2 secant of x. And you can see that the left hand side is a bit lengthier, so it would be easier to prove the left hand side into the right hand side. And whenever in the angle of a trigonometric function, if we have a variable plus minus any other angle, then the first step is always going to be substituting this angle as some other variable. So I'm going to let this angle of x upon 2 plus 45 degrees as some variable, let's say the variable a. So my left hand side would become tangent of a plus cotangent of a. Now I'm going to replace the tangent function by sine and cosine. So tangent of theta is equal to sine theta upon cosine theta. So I'll write this as sine a divided by cosine a. And in place of cotangent of a, I'm going to use this formula: cotangent of theta is equal to cosine theta divided by sine theta. So cos a divided by sine a. Next I'll take the LCM. The LCM would be sine a times cosine a, and sine a times sine a would be sine square a, and cosine a times cosine a is cosine square a. And using the first Pythagorean identity, we know that sine square theta plus cosine square theta is equal to 1. So in place of this sine square a plus cosine square a, I'm going to replace this by 1. So this becomes 1 upon sine a times cosine a. Now in the denominator, I have sine a times cosine a. I have two trigonometric functions getting multiplied by each other. But on the right hand side, which we need to show, has only one trigonometric function. So I'm going to replace this sine a cosine a by one trigonometric function. And if we look at our formulas, there's only one formula in which a sine function gets multiplied by a cosine function. And this says sine of 2 theta is equal to 2 sine theta times cosine theta. And if I divide both sides by 2, I would get 1 upon 2 sine of 2 theta is equal to sine theta times cosine theta. So in place of sine a cosine a, I am going to write 1 upon half sine of 2a. And this is same as saying 2 times 1 upon sine 2a. So this is equal to 2 upon sine 2a. Now for our final step, in place of this a, I am going to substitute my original angle, that was x upon 2 plus 45 degrees. So this would give me 2 upon sine of 2 times x upon 2 plus 45 degrees. And if I multiply this 2 by this bracket, 2 times x upon 2 would give me x. So 2 upon sine of x plus, and 2 times 45 is 90, so sine of x plus 90. And for this sine of x plus 90, in order to expand this, I will use this formula of sum and difference of formulas of the sine function, and sine of a plus b is equal to sine a cosine b plus cosine a sine b. Over here a is x and b is 90. So this would be equal to 2 upon sine of a cosine b, so sine x cosine 90 plus, and cosine a sine b, so cosine x sine of 90. Cosine of 90 is 0, and sine of x times 0 is also going to be 0. So this whole goes to 0. I am left with 2 upon cosine x, and sine of 90 is 1. So cosine x times 1. So if I write this over here, 2 upon cosine x, this is 2 upon cosine x. And I can also write this as 2 times 1 upon cosine x. And 1 upon cosine x, I can use this formula which says that secant of theta is equal to 1 upon cosine theta. So in place of this 1 upon cosine theta, I can write 2 secant of x. And this was the expression on the right hand side. So I have proven this.